Question number 28. A moon of mass m orbits a planet of mass 100 m. Okay. The radius of the planet, this is the moon, this is the planet. Radius of the planet is r. Okay. This is r over here. And the distance between the centers of the moon and the planet is 22 r. Okay. Then what is the distance from the center of the planet at which the total gravitational potential has a maximum value? Is asking you where is the potential maximum. Potential can be maximum here, 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 anywhere it can be maximum. Okay, first let us understand logically what do you mean by this potential. Oh, it takes some time for me to explain. Okay, I will not be able to complete in 1 minute. Let us do this. Now let us say, for example, at a point, if I take somewhere over here, let me take points like A and B here. Okay, now what will happen to a particle? If I take a particle of mass m, keep it here. What will happen to this particle? The particle will move like this or like this depending upon where is the force, right? Which is the resultant force. So here, as I say, it is nearly midway between them. So the force here will be larger. So it is more like this over here, right? So which means, now is this potential at this point, is it maximum? It is not maximum. Okay, because so if this was maximum and this is minimum, particle will move like this. If this was maximum, I cannot locate one more point. Remember, I cannot locate one more point wherein I put it over here so that the particle once again, if it moves like this, okay, if I locate one more point C, if I locate one more point C, then the particle will, if it moves in this direction, that means this has a larger potential. This has a larger potential. Why do I say that? Because particles always move from higher potential to lower potential, right? So in other words, I should now find a point in this line where the particle is neither able to move like this nor able to move like this, right? So let me assume that this is the point where it is neither able to move like this or unable to move in the other way around. Now, which means what? The force due to this planet, F 100m should be equal to the force due to m over here. So these two should be equal. Let me write it down. F 100m should be equal to Fm over here. Okay. So in other words, I should also be able to say that now if suppose if I want to find the feet, I can also say, okay, let me put a mass m here. If I put a mass m here, the gravitational force between these two should be Gm. Let me call this distance from here to here as some x. If this is x, then this distance should be, how much is it totally? 22r, right? 22r minus x. So according to this, Gm into capital M divided by what is this, x square should now be equal to G, and then what is this? Oh, this is not capital M. This is what is the mass of this one here? Bigger planet, 100m. I'll put this 100m should be equal to G into capital M into small m divided by 22r minus x the whole square. Okay, so this G goes away, this capital M goes away. So what I'm left out with, I have here 100m here. I also have a small m also goes away. So I have 100 by x square is equal to 1 divided by 22r minus x the whole square. Newton's law of gravitation, I have applied, nothing else. So taking the square on both the sides, square root on both the sides, I get the answer here as 10 by x is equal to 1 by 22r minus x. Okay, so let me solve for x. When I solve for x, what do I get? I get 220r minus 10x. I have cross multiplied it, is equal to x, or 220r is equal to 11x. X should be equal to 220r divided by 11. 11 ones are 11 twos are. So this should be equal to 20r, right? So thus the answer here should be 20r. Okay.